In this video, we are going to learn about second order partial derivative. The first order partial derivative with respect to x are denoted as f sub x and del f del x. When they are differentiated once again, we will get the second order partial derivative. The partial derivative of fx with respect to x is written as f sub double x, whereas the partial derivative of f sub x with respect to y is written as f sub xy. For notation using del, the partial derivative twice with respect to x is del squared f del x squared. And the partial derivative of del f del x with respect to y is written as del squared f del y del x. For partial derivative with respect to y, the partial derivative of fy with respect to x is written as f sub yx, and the partial derivative of fy with respect to y is written as f sub double y. For notation using del, the partial derivative of del f del y with respect to x is written as del squared f del x del y, and the partial derivative twice with respect to y is equals to del squared f del y squared. From this diagram, we notice that f sub xy is equals to del squared f del y del x, and fyx is equals to del squared f del x del y. In general, f sub xy is equals to f sub yx. In this question, we want to find the second order for the function given, but first we must have the first order first. So the first order partial derivative with respect to x is 10x minus 2y. And the first order with respect to y is negative 2x plus 9y squared. Now we can find the second order partial derivative. The first one is del squared z del x squared. This means that the partial derivative of del z del x with respect to x. Substitute del z del x, then differentiate the function with respect to x, and it equals to 10. Del squared z del y del x means that the partial derivative of del z del x with respect to y. Substitute del z del x, then differentiate the function with respect to y, and it equals to negative 2. For del squared z del y squared, we find the partial derivative of del z del y with respect to y. Substitute del z del y, then differentiate the function with respect to y, and the answer is 18y. And for del squared z del x del y, we find the partial derivative of del z del y with respect to x. Substitute del z del y, then differentiate with respect to x, which is equals to negative 2. For this question, we use power rule to find the first order partial derivative. The 2x comes from the derivative of x squared plus y squared with respect to x. For z sub y, the 2y comes from the partial derivative of x squared plus y squared with respect to y. For z sub double x, this means that partial derivative of z sub x with respect to x. For this function, we had to use product rule because it is a multiplication of 3x and x squared plus y squared to the power of 1 over 2, where both have variable x. So let u be 3x and v be x squared plus y squared to the power of 1 over 2. So u sub x and v sub x are like this. Now substitute into the formula of product rule. Then simplify to find the answer. Z sub yx equals to the derivative of z sub y with respect to x. We only differentiate the red color part because 3y is a constant, so we just rewrite 3y. Then simplify to get the answer. z sub double y means the partial derivative of z sub y with respect to y. We had to use product rule where u equals to 3y and v equals to x squared plus y squared to the power of 1 over 2. Then find u sub y and v sub y. After that, substitute into the product rule formula, then simplify to find the answer. In this question, we want to find f sub double x, f sub double y, and f sub xy. Before we can find the second order, we must have the first order partial derivative. So for exponential function, the first order with respect to x can be obtained by rewrite the exponent, then multiply by the partial derivative of its power with respect to x, which is equals to 2x. For first order partial derivative with respect to y, we will do the same step, but this time the exponent multiplied by the partial derivative of x squared plus y with respect to y, which is equals to 1. Now we can find f sub double x, where it equals to the partial derivative of fx with respect to x. Differentiate by using the product rule, because it is the multiplication of 2x and exponent x squared plus y, where both has variable x. Then find u sub x and v sub x and substitute it into the product rule. Now factorize the common factor to simplify the answer. For f sub double y, it equals to partial derivative of fy with respect to y. Then differentiate with respect to y. So the answer is just the exponent. For f sub xy, it equals to the derivative of f sub x with respect to y. Since 2x is a constant, so we just rewrite it and only differentiate the exponent part with respect to y. And the answer is this. As usual, we must find the first order partial derivative first. So for first order partial derivative with respect to x, we only differentiate exponent 2x and rewrite ln y because it is a constant. For first order partial derivative with respect to y, we differentiate ln y and rewrite exponent 2x because it is a constant. Now we can find the second order. So for f sub double x, it equals to the derivative of f sub x with respect to x. Differentiate exponent 2x only because 2 and ln y are constant. Then simplify. For f sub double y, we find the partial derivative of f sub y with respect to y. So we only differentiate y to the power of -1 and rewrite exponent 2x because exponent 2x is constant. Then simplify it. For f sub xy, it equals to the partial derivative of f sub x with respect to y. Differentiate the function with respect to y and simplify. This question is a proving question which involves natural logarithms. As usual, we find the first order partial derivative first. For natural logarithm, we write 1 over x squared plus y squared, then multiply by the partial derivative of the denominator, one with respect to x and the other one with respect to y. Then find the second order partial derivative, where we had to use quotient rule. So let the numerator and denominator be u and v respectively. Then find u sub x and v sub x. Then substitute into the quotient rule and simplify. For second order partial derivative of del f del y with respect to y, we will use quotient rule as well. So u and v are numerator and denominator respectively. Then find u sub y and v sub y. Substitute into the quotient rule and simplify to get the answer. Now we can show that the sum of both second order partial derivative is equals to 0 by substitute the second order we get just now and show that it is equals to 0. This question also a proving question involving second order partial derivative. So the first order partial derivative can be obtained by using the power rule. F sub double x means that the partial derivative of f sub x with respect to x. Differentiate the function with respect to x by using power rule to get the answer. For f sub double y, this means that the partial derivative of f sub y with respect to y. Differentiate the function with respect to y by using power rule 2 and simplify to get the answer. For proving part, we prove from left hand side, so substitute f sub double x. Simplify, and this is actually equals to f sub double y.